Yo, 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 yo. All right, everybody. 9.1 properties of translations. We are getting into geometry. So there's going to be a lot of vocabulary that we need to know in this section. The key terms are very, very, very important. This whole section is about transformations. So all of Module 9 is about different types of transformations. What a transformation is it's when we change the position, size, or the shape of a figure. We're going to deal with shapes. So we're going to look at a triangle, and we're going to change the position, the rotation, or the size of this triangle. And we're going to do so, and by doing that, we are performing transformations of this triangle. You'll see what I'm talking about in just a little bit. So in order to perform transformations, we start with our pre-image. So that's what the beginning, that's our starting image. Let's add that to this key term. We're starting with the pre-image. So the starting figure is the pre-image. And the image is the resulting figure after the transformation. So we're going to have a pre-image, and then we're going to transform it, and then what we end up with is our new image. So today, all we're going to focus on is one type of transformation, and that's the translation. So a translation is a transformation that slides a figure along a straight line. When we perform a translation, we don't change the size or the shape. We only change where it's located. So what a translation does is when I take this triangle, if I were to look at just this triangle right here, so let's look at just this triangle. It's not letting me select just the triangle. That's okay. So if I were to take just this triangle, it's taking the whole thing. I didn't want to do that. No. Okay, no big deal. So if I was going to take just this triangle and I wanted to move this triangle maybe over here, I would just keep the same shape, and I would just take this triangle and I would slide it over there. Okay, and we're going to look at some examples of that right now. So here I have a triangle XYZ. Here's the pre-image. This is the beginning one, right? This is what we're starting with. Okay, so here's the pre-image. I'm going to write that down. And now what I'm going to do with that pre-image is we want to translate it 4 units to the right and 1 unit up. So I'm going to take each point here on X, Y, and Z, and I'm going to translate it 4 to the right and 1 up. And that's it. So I'm going to slide this whole triangle over 4 to the right and 1 up. So it's really just counting on the coordinate plane. So I got to take X, go 1, 2, 3, 4 to the right, 1 up. There's my new X. And then to write the new one of the image, we put a little apostrophe on it. That's showing me that this is the new X, this is the image. And I'm going to do that with all of these. I take the Y, I slide it 4 and 1 up. So there's my new Y, and I have that little apostrophe. Z, same thing, 4 to the right, 1 up. There's my new Z with the apostrophe showing that that's the new one. And then from here, you would just draw your new resulting triangle or your new image. So when I draw this new image, if we notice, it is the exact same shape as the initial pre-image. So this is the same size triangle. It's the same shape of the triangle. The angles are all the same. All we did is I took this triangle and I just kind of slid it over here to this new position. So I performed a translation by sliding everything over, and these are my new points. So here I have a parallelogram. I'm going to do the same thing. I'm going to translate it, which means I'm going to slide it 4 to the left and 2 down. So I'm going to take every point, I'm going to slide it 4 to the left and 2 down. That's just counting. So this new, here's the original piece. I'm going to slide this piece 1, 2, 3, 4 to the left, 2 down. And then I'm going to write the new point with the apostrophe there to show that this P translated to this P. And I'm going to do the same thing with each and every single one. Q, 1, 2, 3, 4, 1, 2. There's the new Q. S, 1, 2, 3, 4, 1, 2. Here's my new S. And then R, 1, 2, 3, 4, 1, 2. And there's my new R. And then now again, when I connect these points and I redraw the shape, if we look, it's the exact same shape. Same angles, each line's the exact same distance. Like this Q to R is still 1, 2, 3 down. That's 1, 2, 3 down. Same side, the side lengths are the exact same size. Everything's the same. I just slid it over to the left and down. Now, one thing I wanted to point out is this is another way that you're going to see this. So here, I want you guys to do this, but I want you guys also to write something extra down. So 5 to the left and 2 down. Okay. Sometimes you're going to see this written algebraically. So every time we take a point, it's x and y. Okay. So x is always the first number in an ordered pair. Y is always the second. So another way you're going to see this written down, instead of like a big paragraph right here, hey, we're going to translate this parallelogram 5 to the left and 2 down. What it also might tell you is this 5 to the left, when we go left and right, we're changing the x value. So if I were to go like 5 to the left from here, A would go 1, 2, 3, 4, 5. I just went backwards. I went left on the number line 5. I went from 0 to -5. So what I did is whenever I move to the left, I'm subtracting 5 from my x. If we move up and down, we're adding and subtracting from our y. So 2 units down would be subtracting from the y, because when we go down, we subtract. When we go up, we add. When we go left, we subtract. When we go right, we add. This right here, so make sure you write this down, this right here is another way of writing down 5 units to the left and 2 units down. You're actually going to see this on a test of some kind or a quick check where you're going to be expected to know that if I say, hey, you're going to take your x and y points, you're going to subtract 5 from each x value and subtract 2 from each y value. That means that you're sliding the x value to the left 5 and you're sliding the y value down 2. Okay, and that's going to give you your new point. So let's look at why that is. So again, this original A right here, the x value is 0, the y value is 1, 2, 3. Well, I went 5 to the left and 2 down. Well, if I take this and I actually do this right here, where I actually take my x value and I subtract 5, and then I take whatever the y value is, 3, and I subtract 2, it should give me my new point. Well, my new point should be at -5, 1. Well, -5, 1. That's where it is from us counting. Okay, so you could actually do this without even counting on a graph. So you should be able to do the translation without counting it on a graph by just adding and subtracting from the x and y values by which direction we're going. Okay, so here's what I want you to do though. I want you to finish this new image. So we have the pre-image. I want you to finish sliding B, D, and C, and then see where they end up, redraw it, and go from there. Okay, so pause it, try it, see how you do. Okay, so let's see. 1, 2, 3. So 1, 2, 3. So here's the new B. Okay, so D, I'm going to go 5 to the left. 1, 2, 3, 4, 5. 2 down. 1, 2. Wait. Yeah. 5 to the left, 2 down. There we go. There's the new D. Notice I'm including the letter with the apostrophe. You have to do this when you graph it. Okay. And this one's 5 to the left and 2 down. So there is my resulting image. So this is the final image after we performed the translations. And again, same size, same shape, same direction. I just slid it over to the left and down. Okay. Here's what I want you to do. I want you to translate this, or not translate, I want you to write the algebraic representation of this one, and then I actually want you to do it as well. So translate it 5 units up and 3 units up. Okay, so 5 up, 3 up. Okay, go. Okay, so here's the algebraic representation. That's just x plus 8. The reason why is it's saying we're going up, and then we're going up again. So I went 5 up, and then I'm going 3 up again. So really I'm just going a total of 8 up. I'm not doing anything with my y, so I don't even need to write anything. We're not going left and right. Oh man, I'm backwards though. Ooh, I'm glad I caught that right now. Whoops. I'm not going left and right, so my x stays the same. And then because y is what changes up and down, I'm taking whatever my y values and I'm adding 8 to those. Sorry, I hope I didn't confuse you there. So I was backwards. So up and down is always the y value, left and right is always the x value, so this would be the algebraic representation. This is how we would write it in this format. And here's your new image. Yes, it was off the graph. I just did 1, 2 above the graph, and this one went 3 above, and it still shows the same shape. Okay, that is all. Okay, so one thing I want you to put in things to remember is, again, put x and y, and then show x, and then x is left and right, y is, and then draw arrows up and down when we're shifting. So whenever we're adding and subtracting from our x, we're going left and right. You can even go negative and positive, showing if we're going left, we're subtracting. If we're going right, we're adding, and negative and positive on the arrows over here as well. Okay, and then that is it. Here's your independent practice. That's all I got for you guys. You have to describe the translation, so tell me, okay, well, how many did it move up and down, up and to the right, and then give me the algebraic representation. Okay, guys, thanks for watching. I hope this helped. Goodies out.